Hi everyone, welcome. We're going to be looking at our Unit 2 lab today. That's from Lesson 2.9, and it's about the island chain of Hawaii. So it's called Island Chain Formation, Lab 2.9. Let's take a look at where Hawaii is located. So here we have a sort of zoomed out Google map. We've got the west coast of the United States and Mexico over here, and we can see Hawaii out in the middle of the Pacific Ocean. So here's the Hawaiian island chain. And we are going to be looking at how these formed. What kind of volcanoes created the Hawaiian Islands? Lots of volcanoes that we were talking about in this unit occur at the edges of tectonic plates. So here we have the North American plate and the edge of the Pacific plate, and we have volcanoes along the coast of that plate interaction. But these islands don't occur at the edge of a plate. So the volcanoes are not where two plates are meeting. They're in the middle of a plate, and we call those hotspot volcanoes. So it's a separate type of volcano, hotspot volcanoes, and we'll look at how they form. So hotspot volcanoes can result in the formation of an island chain, and we see that here. Hawaii is a wonderful example of an island chain. The first thing that happens is the hot magma erupts to form an island. So here is the mantle, that's the layer of the earth which is under the crust, and that mantle is very hot and it's moving, and as it heats up it can rise up and it can break through the crust, and so that mantle erupts, it cools down when it hits the ocean water and hits the air, and it forms an island if enough of it erupts to reach out of the water. Then the Pacific plate moves. So the Pacific plate, where that mantle has cooled down, where that island is formed, is moving. The Pacific plate, just like all of the other tectonic plates, is in motion. And so the Pacific plate happens to be moving to the northwest. So that plate is going to carry the island that has formed over that hotspot away to a new location. So the Pacific plate continues to move, which carries the island away. And then step 3, a new island forms on the Pacific plate on the spot that is now positioned over the hotspot. So once that island slides away, a new area is going to be positioned over this hotspot. So new magma is going to erupt and a new island will form. Over time, the older islands are exposed to wind and rain, so they weather and are eroded away. This decreases the size of the islands over time. So you can see down here that the newest island, the island of Hawaii, also has mountains and volcano peaks that are the highest altitude, whereas over time, these older islands that have been drug away from the hotspot, which was down here, those islands have also decreased in size over time. This is all information that you're going to need as you open up the document, so let's do that together. We'll take a look and see what you need to answer the questions in the lab. So once you have your document opened, this is called the Island Chain Formation Lab Report. We will look through the questions together. So the first piece of information you're given is a diagram that shows the Hawaiian island chain, and it gives you a map with elevation data. So it shows you the numbers in green are the lowest elevations, and we move up to yellows, browns, and then even grays, and those are the areas of highest elevation. So question 1 says, examine figure 1 above that shows the elevation of each Hawaiian island. Do the islands appear to be the same age, or are they older at one end of the chain or another? Explain what evidence about the island elevations supports your data. So your answer for this question should just be, do the islands look the same age? So you can say, yes, I think the islands look to be the same age all the way across the chain, or no, I think some islands are older than others. And what evidence do you use? And you'll take a look at the evidence that we were given and the things that we just talked about regarding the Hawaiian island chain, and just show me what supports your data. The second question says, where are the new islands forming? So again, thinking back to what I told you about hotspots and how hotspot islands form, where on this map would you expect the new islands to be located? So you can either use directional terms and say, I think the new islands are forming to the south, to the north, to the northeast, whatever it is, or you can even put a star on the map or put an arrow on the map where you think the new islands are forming. For questions 3 and 4, you're going to use these figures, and so I've just rearranged them so that they'll be on the same page. So it looks a little bit different than it will look in your document, but it's exactly the same information. So figure 2 shows us the direction of continental plate movement. So we have all of the continental plates here. We're focusing in on the Pacific plate, which is shown in this bright yellow color, and the red arrows indicate the movement of the plates. So take a look and see what direction, maybe focus in on arrows like this one, this one, this one, so that you can see what is the trend in direction of Pacific Plate movement. The next diagram is really the same, but it points out where Hawaii is located on that Pacific Plate. So Hawaii is kind of up here if you were to look at it on Figure 2's diagram. Figure 3 doesn't show you the arrows of plate movement, but it does show Hawaii's location. Okay, let's take that information and jump down to look at the next set of questions. Number 3 says, look at Figure 2 and 3, which shows Hawaii's location and the movement of the tectonic plates. What is the direction of movement for the Pacific Plate? How does this compare to the trend in direction of the island chain? So go ahead and give me an answer that describes what those red arrows looked like in Figure 2. What direction are they moving? And then say, how does this compare to the movement or the pattern of island chains that we see for Hawaii? Question 4 says, use information from Figure 2 and 3. Figure 2 shows the direction of movement for the Pacific Plate. Figure 3 shows the location of the Hawaiian Islands as well as the Hawaiian hotspot where magma escapes from under the Pacific Plate. Develop a hypothesis about how the Hawaiian island chain is forming. So this is where you just kind of bundle all of that information together into one statement. I think the Hawaiian island chain forms, and then you fill in the blank here. That's one way to begin your answer. You don't have to begin your hypothesis like that, but just give me some explanation of how you think, based on the information you've learned about hotspot volcanoes, based on the information you have learned about how the Pacific Plate is moving, how do you think the Hawaiian chain formed? In the next part of this lab, we're going to test your hypothesis and we're going to be plotting your data. So we are going to take data about the Hawaiian Islands and we're going to be looking at different volcanoes from those islands. So this gives us the names of the volcanoes, the distance from Kilauea, and that's the sort of newest or most southeasterly island. And we're going to look at the distance of all of these other volcanoes from this one. We'll look at their elevation and we'll also look at their age. And this age is using radioactive data. So rock samples were collected from the different islands and analyzed for the radioactive material that was contained in them, sort of like carbon dating. And that was used to calculate an age of the islands. And the MYA stands for millions of years ago. So the island was formed this many millions of years ago. Kilauea, we know, erupted very recently. If you notice in the news, maybe in the past 3 years, we were even talking about major eruptions in Hawaii. So the rocks here are not even 1 million years old yet. They are very newly formed. Okay, let's take a look at what the questions are, and then I'm going to jump over to Excel and show you how to create those graphs. So for number 5, it says graph the distance of each volcano from Kilauea versus the age of that volcano. Then draw the trend line. So you can do that using the graph that's given here, or you can just jump into Excel, make your graph, and then you can come back and paste it in here. Again, I'm going to have a separate video that shows you how to do the graphing. You should aim to have an equal number of points above and below your trend line. So we're going to make a trend line that shows distance of each volcano versus the age of the volcano. And we also have those labels shown here on the X and Y axis, so you can know how to label your graph if you do it in Excel. If you do it by hand, that's great too. Just use the data from this data table. So we're looking at distance and we're looking at radioactive age, and you are going to plot those on the graph. So you're going to just make like a scatter plot, and then you're going to come back and fill in with a trend line. For number 6, it says we're going to analyze that graph. So look at your distance of each volcano from Kilauea versus the age of the volcanoes, and describe the relationship between a location's distance and its elevation, and explain how it supports or does not support your hypothesis. So you'll take a look at the way that trend line looks in your graph, and you'll say, yes, if the islands are older in one area than another, or whatever you stated in your hypothesis, you'll just connect and say whether or not this graph supports that data. Question 7 is taking a look at the data from a separate angle. So we're looking at the distance of the islands from Kilauea. So how far are they from the island of Kilauea, which is the one that's most recently erupted, versus the elevation. So now we're taking a look at that map that shows us elevation data. Be sure to label the X and Y axes. So we have the axis labels here, or if you make your graph in Excel, you can create your own axis labels. Once you have that, question 8 says, look at your distance versus elevation graph. Describe the relationship between age of the volcano and distance from Kilauea. So as you go further from Kilauea, do the volcanoes get older or younger? And use your graph and go back to your original hypothesis and see, are those two things linked? Question 9 says, go back to your original hypothesis. Does the data that you analyzed here, does the data that you graphed support your original hypothesis, or do you need to maybe rework things and come up with a different hypothesis? And then question 10 is an if question. This is a scenario. It says that the radioactive dates represent years of research from different teams. But, and this is where the question is really hypothetical, but if radioactive dating was not a reliable sort of piece of information or scientific data point, would the data show a trend, or would you expect the points to be random? So take a look at your graph that shows the radioactive age of the different volcanic rocks, and do you see a trend? Do you see a trend in that graph? And if radioactive data was not reliable, would you expect that graph to be the same, or would you expect the points to sort of just be all over the place? That's how you answer the questions for this lab. Let me know if you need any help, and I'm going to link to my next video so that you can see how to do the graphing in Excel.